Okay, today you're learning about recursively defined sequences. There's going to be a lot of terminology. You are going to have to pay really good attention or you will get lost quickly. Okay, right now I'd like you to be on this page that I'm on. Some of you are not. Get there now, please. All right, number one, recursion. That is a process in which each step of a pattern is dependent on the steps that come before it. I'll give you a really simple example. 2, 4, 6, 8. It always depends on what the number is in front of it, right? I mean, I can't just like start this pattern with a 3 and do the same exact pattern. I have to depend on the number in front. So like I do a 8 and then I can do the next number. And the next number you just add 2, 10. This is a sequence and it's called a recursive sequence. All right, pretty much every sequence that you have done in the past has been a recursive sequence. All right, so a sequence is just an ordered list of numbers. A term is just like one of these. That's a term. And a recursive formula defines a sequence, and it would have a starting term and the rule to tell you, like, start with 2 and then count by 2s. Except we say it this way, which looks much more complicated. This is one, and this is a separate one. All right, just look at that for a second. When it says U1 equals 5, it's hard to know exactly what they're talking about there. And then it says UN equals UN minus 1 plus 4. Extremely complicated looking. So let me try to make this simpler for you. Let's say you had a sequence like this. 5, 10, 15, 20, 25. And let's say I just start in the middle of it. And I don't even know where they started this, and I don't know where you're going to end that. Do you get how I could go forever in both directions? So then I don't know which term this one is. It could be like the 9th term in the order. I don't know what they started with. So if I don't know which term it is, I call it U sub n, as in a variable. If I would have known that it was the first term, like for instance, if I go like this, 2, 4, 6, 8, then I know that's the first term, then it's called U sub 1. If it's the first term, it's U sub 1. But if I don't know which one it is, it's called U sub n. What would be right in front of U sub n? And don't say U sub L, M, N, so there must be U sub M. Don't change variables. Yes, sir? Perfect. U sub n minus 1. And what would the one right after this guy be? U sub n plus 1. Does that make sense to you? All right, then you'll understand this formula just a little better if I said that U sub 1 was 0, as in I started with the number 0. U sub n is given by U sub n minus 1. That means any random term is given by the term in front of it plus 5. Get how I was adding 5 each time? So this is saying start with a 0 and then keep adding 5 until you get to the number you want. So 0, 5, 10, 15, 20, blah, 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 blah. Keeps going. All right, see if you caught on to that. I'm going to give you one. U sub 1 equals 10. U sub n equals U sub n minus 1 plus 4. Tell me what the first 3 terms of this sequence are. Don't say it, write it on your iPad. Turn it my way and I'll tell you if you're right or not. The first 3 terms. What, comma, what, comma, what? Correct, sir. Make it a little bit bigger. I can't see that quite. I think you're adding 10 each time. You don't want to do that. Yes. Wait a minute, though. Starts on a 10, so that one's right. That one's right. That one's right. That one's right. 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 Actually, some of you are giving me 4 terms, but that's okay. Good. Good. Zoom in on it. Can't see it. Yes, I can barely read that. Turn your brightness up just a little bit for the next couple minutes. Yes. 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 Did I ever see yours? Good. Okay. 10. I told you to start with 10 by telling you this. Then what comes next? I told you what to do by saying that. Add 4, so it's 14. And then the next term is plus 4 again, 18. And some of you went one more place, and that's not really good because I said to give me the first 3 terms. And if you go here, you've given me the first 4 terms. This is the first term. This is the second one. That's the third one. So I really didn't want that one. Be specific. If I ask for the first 3 terms, those are the first 3. Okay. Now, do you get when you're counting items? How many items do I have on my desk? Do you see I have 3? Do you get I'm not going to count 0, 1, 2? That'd be kind of weird. But do you get how in the real world, when we do a math problem, a lot of times we start at times 0. It's like at the 0, 0 point on the graph. So sometimes you have to start with 0 instead of a 1. Most of the problems today you're going to start with a 1 because we're going to be counting items or counting terms. But in the real world, sometimes you start at times 0. Then it could look like this. U0 equals, let's say at time 0 you have $100,000 in your bank account. Great Aunt Tilly left you some money for college, okay? And then U sub n is equal to U sub n minus 1. That means the term, any random time is given by the time right in front of it. And let's say that we're going to say that your money grows by 6%, 1.06. That means it's going to go up 6% every year. So you start off with 100,000. At the end of the year, you got 106,000. Because why? Because your investment is growing. They're giving you interest. Or maybe you're making money on stocks or something. All right, so this is a problem where we started with a 0 instead of starting with a 1 as my first number to count with. Not going to do that too often today. Most of the time we're going to start with a 1. All right, I'm going to go back to a more normal one. U sub 1 equals 200. U sub n equals U sub n minus 1 times 3. What are the first 3 terms? Yes, sir. First person's figured it out. Close your last number's off a little bit. Try to figure out why your last number's wrong. First 2 are good. Yes, 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 yes. Getting a huge streak here. Yes, yes. Okay. So that was 200. And then 600. Most people did that right. And you're timesing by 3. You don't go back to the original one and times it by 3. You take this one and times it by 3, 1,800. All right. Any questions on that one? All right. Now, this wasn't that bad because I was only asking for the first 3 terms. What if I asked you for the 43rd term? Do you get how that'd be a real pain in the butt? You could do it, but it'd be a pain in the butt. There's a calculator for that. That's why we have the calculators out. Everybody grab a graphing calculator. And I'll show you how to put these into the graphing calculator. Okay. You may think, where in the heck did you get all that stuff? It's because I changed my calculator's mode. Everybody go into mode. First of all, in general, you should not be in radian mode because you don't even know what a radian is. You will when you get to pre-calc, but you should be in degree mode because if you want to type in like 30 degrees and figure out like sine of 30 degrees, if you type it in radian mode, you're going to be saying what's sine of 30 radians. You don't even know what a radian is. So I'll teach you that later if you want to know, but you'll learn it in pre-calc. For right now, be in degree mode, and then the last part is this. You are in func mode right now. What do you think that stands for? Function. Very good. And I think this is parabolic and polar. I'm not sure, though, because I've never even used them before. That one is sequence mode. Everybody get to your blinking light onto the SEQ, and then hit enter to make it stick that way. Okay, now you're in sequence mode. And the way you won't be able to even tell, except for one button now is completely different than it used to be. The y equals button. Everybody hit the y equals button, and instead of seeing a bunch of y equals, y equals, y equals, you now have this. And this is for sequences. Under y equals, it should look like this. Now, you remember how I said most problems today you're going to start with u sub 1, but sometimes you can start with u sub 0 if it's a more complicated real-world problem. I hope your calculator defaulted to a 1 on the top. Did it? Good. Now don't touch that. That is not the first term. That is saying, what is your smallest n number? The n numbers are these guys. Basically, it means, what are you going to start with? Are you going to start with a 1 or a 0? Because that's like 98% of the time in this class. It's going to be a 1 or a 0 right here. And in most of the time today, it's going to be a 1. So that's the first thing you tell it is, what do you want to start with, u sub 0 or u sub 1? And we wanted to start with u sub 1. This next part, yours is blank, so I'll make mine blank to be like yours. And here's what you do. U parentheses n means u sub n. The calculator can't do subscripts. It doesn't have a good enough screen to do that. Not actually, in the new upgraded software on it, you can actually do subscripts. But anyway, so it's trying to say u sub n. Look at my formula. What always comes after u sub n? It equals what? U sub n minus 1. That's the part we have to do next, and then like times 3 or whatever. So this part right here we have to type into the calculator, but we'll only have to type it once, because every single problem you do, you're going to have u sub n minus 1 right there. You won't have to change that over and over again. You can just change the number after it. So what I mean is, oh, nuts. Just got really big. Just a second. See if I can shrink this thing down. Whoa. I did a magic trick. I made it disappear. Okay. I don't know what happened there, but I'll try it again. I've got Gigantor calculator. I'm trying to make it smaller, but it's just moving it. Come on. There, I made it smaller again. Man, it's a pain. Okay, I got to work on that software. U sub n equals, how do you get u sub n minus 1? You need a u, first of all. Where's the u? Anybody find it? It's above what? The 7, very good. It's above the 7, so second 7. Now I got my u in there. Again, if you do this right and you don't by accident delete it later, you'll only have to type this once. U sub means parentheses. N minus 1. Where is the n? It's on the same place as where x usually is. It's on this key right there. I'll leave it red so you can find it. U sub n. And now everybody knows how to do minus 1. You just do minus 1. Minus 1. End parentheses. Nice if he joins. Catch a graphing calculator? All right, try to catch up to me. We're on, actually hand it behind you. And Mr. MQ, would you make his calculator in the right mode for him? Okay, so u sub n minus 1, and then I want to do, what was this problem I was just doing? Times by 3. So I'm going to say times 3. Everybody, go times 3. Times 3. Enter. What haven't I told the calculator yet? What do you want to start with? Yeah, we were starting with 200, so put a 200 right here. So we start with 200, and we're timesing by 3 every time. Now, what if I wanted to find, I'm not going to do a ridiculous number because it'll take the calculator too long to calculate, but let's do like the 12th term. So what do we do? Well, first of all, we quit out of this. Go second quit. If you want the 12th term, don't you want u sub 12? Then put in u, which is right above the 7, u sub, parentheses, 12. And you have just figured out the 12th term of that sequence, which is about 3.5 million. Or no, 35 million. Sorry. Big difference. I'd rather have 35 million than 3.5 million. Either one would be better than what I have right now, but okay. The u is right above the 7. And the sub is the parentheses. All right, let's see how fast you guys catch on. I already gave you a walkthrough one time, but let's see if you got it from that. I'm going to give you a sequence. You tell me what to type into the calculator. Actually, you just type it in and see if you can figure out the answer. So here'd be a typical question. I want to start with 25 this time. Un equals un minus 1, which means any term is given by the term right in front of it, plus 7. And I want to know what is the 21st term. You know how to put that into the calculator. Remember, that first number, that's not where you put the 25. The first number on your calculator that you put in under the y equals is a 1. It's already there. 21st term. Put it on your iPad, turn it my way. Good. Yes, 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 yes. You got it right. Good. Something's wrong with your last digit. Yes, 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 yes. Pretty much everybody, if even he's getting it right, we must be doing this pretty well. Okay. Now I'm going to show you how, for those at home that weren't sure how that worked, I had to add 7 each time. I'm going to go over here and make a plus 7 right there. Plus 7. And then I wanted to start at what? I wanted to start at 25, so I put a 25 right here. 25. And then I just go second quit to get out to the main screen. And this time I don't want u sub 12, I want u sub 21. It's kind of a dyslexic thing there, so hopefully I can do this right. U, which is above the 7, sub 21 instead of 12. End the parentheses and hit enter. And there you go, 165. Okay, one more cool way to do this is the table. Everybody go second table. Why does it say error up until I hit 1? Because that's where we started. Before that, sequences can't go backwards. You and I are smart enough to go backwards. And we could say, well, if you're starting at 25 and you're adding 7 to get each extra 1, well, then this next one must be like 32 and etc. because I can add 7. I'm also smart enough to just go, well, logically, then what should be in front of the 25? Take 25 and do what? Minus the 7, and you get 18, yeah. So the calculator, though, is not smart enough to do that. And it's technically not defined before 25. There's nothing before this. So it's supposed to say error like it does. All right. So which one is better for finding the 400th term? Well, I can find the 400th, but I'm going to have to hit down arrow a bazillion times. So yeah, it's not that awesome. It's not bad, but if you want a large number term, it's better to just quit out of this and say I want u sub whatever. So that's right above the 7. U sub, let's say the 89th term. Nah, I don't need to get complicated and add stuff to it. I'll just enter. 89th term would be 641. Get the idea? You have just learned some pretty complicated stuff, and there's some terms that go with it that you wouldn't know yet, and I got to explain those to you, but then you'll be done. All right. So these terms that we were just making, this list here, okay, first term, second term, those are called terms. The whole thing is called a sequence. This is called a recursive sequence. Recursive. The next thing is, if you're adding or subtracting something, that makes them what are called arithmetic sequences, as opposed to if you were multiplying by 7, that would be a geometric sequence. And the last thing is, that thing then isn't called, it's not called the same thing if you add versus if you subtract. I'll give you an example with numbers. 2, 4, 6, 8. You get on with me adding 2 each time? That's called a common difference. When you multiply up and you start with like 6 and then you multiply by 2 is 12 and you multiply by 2 makes 24, that isn't doing the same thing each time, is it? At least not adding the same thing. So that's multiply by 2. That's not called a common difference because if you subtract those numbers, it won't work. What do you have to do to these two numbers to get 2? Divide them. So it's not called a common divide, it's called a common ratio. So this is called common difference because you actually subtract, and that's what difference is in math, is subtracting. And this one is dividing the bigger one divided by the smaller one, and then, or sorry, the one on the right divided by the one on the left, and that is called a ratio. So this number is called a common ratio. So that's a bunch of terminology, and now I'm going to see if you really understood the terminology. I'm going to say it in words to you. You try to write for me what the little sequence is then. Your n-min is 1. Your starting term is 12. Your n-min is 1. Your starting term is 12. It has a common difference of 3. Your n-min is 1. Your starting number is 12. It has a common difference of 3. What is the fourth term? And don't show me answers yet. I know some of you already have them, but fourth term. Your n-min is 1. Well, that's the first thing on the calculator is the n-min. What that means is you start with a u sub 1. And it equaled 12. 12 was our first term. And then you always go un equals un minus 1. And this time I said the common difference. Does that mean you're going to add or subtract them? Or sorry, add, subtract, or multiply, divide. Which one is it? It's add, subtract. Okay. And in this case, it's adding, what did I say? 2, 3, 3. Okay. And then if you want the fourth term, you got to list them. 12. The next one will be 15. Next one will be 18. Next one will be 21. Raise your hand if you figured that out. Awesome. Okay, that's just using the terminology, which can make it sound really impressive and complicated, but it's really not that bad. You've done sequences since you were a little kid. Math's all about recognizing patterns, so this shouldn't be that bad for you. All right, the assignments. There's, instead of one big long assignment, it's actually broken in 2 chunks. It is a little too long, though, so I'm going to have you skip 6 problems, one of which has 3 parts. 2 of them have 3 parts on them, so it's fairly simple. You're going to skip problems 3, 6, and 9 from both worksheets that are assigned today. And I think you'll see that they go pretty fast. So problems 3, 6, and 9 are skips. So I'm going to show you. Here's the first worksheet called Arithmetic Sequences. And you may skip 3. And where's 6? 6 isn't even on my screen, so I guess it is just barely. That's 6. Okay. So then, this starts off at baby level, like super simple. It just says what's the first, second, third, fourth term. Don't use a calculator for this. It's a waste of your time. You can do these in your head super easy. The first term's 20. And then if you know the little sequence thingy, it's saying what to do right there. So what's the next number? I know some of you are already ahead of me. So 26, 32, what's the last number? Come on, somebody. Okay, if you're not, appreciate that. If you're not going to stay with me, I think it must mean that it's super easy for you, so that's good. Number 2, you just start with 47, and then you subtract 3 each time. I'm going to move down to number 4. It says, write a recursive formula. Yes, you have to do this on paper, but you can use your calculator at any point on this worksheet. But to write the formula, your calculator can't write the formula for you. It can figure out the 10th term, but you have to write the formula. You always start with u sub 1 until we get to the complicated ones where they're real world problems. If there's any on today's homework, which I think there might be one, that's talking about a real world problem where the balloon starts flying at this time or whatever, I think it's easier to start with a sub-zero then, but for right now, while it's easy, use u sub 1. And that's our first term, and our first term in this case is a 6. And then I go un equals un minus 1. And then I just got to figure out if I add or subtract the 3.2. And it says a common difference, it's supposed to be difference of 3.2. And that means you add it. The difference kind, you're going to always add, unless you're adding a negative. I know it's kind of cheating, but. And the ones that are a geometric or a common ratio, that kind you're always going to multiply. And if you want to really divide, then you actually just multiply by a fraction. So that we can say we're always multiplying or adding. Okay, good. I got my little formula. We're going to talk more about what's called the domain tomorrow, but for anybody who's like, wait a minute, my teacher taught me about the domain, if you're listening to this video at home, the domain on this one would be n has to be greater than 2. Or equal to, sorry, greater than or equal to 2. What that is just saying this sequence only works starting at the second term because it relies on the number in front of it. So if my numbers are like this, 6 and then 9.2 and then 12.5, etc., I can't really use this formula except starting right here because it always depends on the number in front of it. And if I try to start right here, it doesn't have any number in front of it. That's why the sequence really only works starting at the second term. I know it's complicated, but we'll talk more about this tomorrow. That's called the domain. All right. So final answer on that one is the 10th term. Does anybody have a calculator and has already figured it out? What did you get? Who got the same thing? All right, there's a lot of smart kids got that, so that's probably it. Okay, let's move on to the geometric. If you look at the geometric, it's identical to this. It's basically the same exact thing, except instead of adding or subtracting, you're multiplying. So we decided to cut it. It used to be 2 days, but last year we started to put the 2 days together because it was like insultingly easy for you. If you understand it with adding, then you change it to multiplying. It's just the same thing. So we squished and saved a day there. Okay. And that does give us a day right before spring break where we can have a more laid-back, fun day right before spring break. So, any other questions you guys have? So your assignment is these 2 worksheets that are posted at the same time here. The one's called arithmetic, one's called geometric. You may skip 3, 6, and 9. Last question. Yes, on both of them. Yep. Okay, that's all I have for the video for today.